Hello and welcome back. Today we are going to continue our discussion of exponents that we started a few classes before. So today's title is Using the Laws of Exponents and Simplifying Expressions with Negative and Zero Exponents. So first of all, let's go over what the important terms are when you're studying something like this. Let's see, 1, 2, 3, we have some rules here. 1, 2, 3, 4, 5. We have 5 main rules when you're dealing with the laws of exponents and expressions that have exponents in them. So you can make yourself some little flashcards if you want to study these and memorize them. When you're multiplying 2 or more monomials that have the same base, you just add the exponents. So if you were to see something that said n to the power of 3, n to the power of 2, these have the same base. What you basically do is just add the 3 and the 2. So you have n to the power of 5. Now, if they didn't have the same base, then you would not be able to multiply them together. For example, let's say you have over here you have a to the power of 4 times n to the power of 3 times n to the power of 2. Well, the final answer would be a to the power of 4 times n to the power of 5, because you can add the exponents when there's when the base is the same. You can do these two, but you can't do the 4. So you would just write it separately, and the final answer would be an expression that is a multiplication expression multiplying these two monomials. Okay, when you divide exponents, you're going to use subtraction rules for that. So let's take n once more. N to the power of 3 over n to the power of 2. That is simply going to end up becoming n to the power of 3 minus 2. And the final answer would become n to the power of 1. And we all know that that's just implied n. So your final answer is going to be n. Okay, let's take a quick look at power of a power. When you raise a power to a power, you're going to keep the base and just multiply the exponents. So let's write one up really quick. N to the power of, let's see, 3. And let's have this all raised. Let me change that to a 2. We'll have it all raised to the power of 2. And you'll see these. You'll see that there's a power, but then there's another number outside of that that's a little higher. And the parentheses should tell you exactly how it's separated, because when it gets more complicated, you will have more terms. You might have two binomials. You might have a binomial and a monomial raised to the power. So pay attention to how it's grouped so that you know what this power here, what the power on the outside is going to apply to. Let's say you had something in front of this, like x. X times n to the power of 3 to the power of 2. Well, this would only apply to n to the power of 3 because x is outside of the relationship. Now, if you wanted to do something like this, put it in brackets. Okay. So then you could rewrite it as x to the power of 2 times n to the power of 3 to the power of 2. So it's all about the grouping symbols. Okay, so let me erase this. In our original problem here, of n to the power of 3 all raised to the power of 2, you will multiply the power times the power that it's raised to. So the final answer here would be n to the power of 6. Okay, let's move along and talk about negative exponents. Let's say you have something like n to the power of 2 over n to the power of 3. Negative exponents, sometimes the problem will have it already there. But many times the negative exponent will be your answer that you've derived after you've done your computation. So basically you can't leave it like that. You have to do something to it to make it right, because a negative exponent is technically incorrect, so it has to be rewritten. So what you're going to do is use the rules for dividing here, which is to subtract. So the first thing that we're going to get after this is n to the power of 2 minus 3. The next thing we're going to get is n to the power of negative 1, because 2 minus 3 is negative 1. So what you're going to do with that is turn it into a fraction, n to the power of negative 1 over 1. And you're going to flip it and reverse. You're not going to reverse the values, because the 1 is going to stay the same. But instead of dividing 1 into n to the power of negative 1, you're going to divide n to the power of negative 1 into the number 1. So let's write the reciprocal and change the exponent to a positive. And there you have it. You're dividing into 1 now. And that's doable. So that is going to be our final answer here. And these get much more complicated. Okay, 0. 0 is an easy principle. Let's say you have (21 to the power of 0). That's going to equal 1. Anything raised to the power of 0 always equals 1. And I forgot the logic behind that, but it's just one of those that's easy to remember, so you don't have to think too much about it and get into the theory of it. Okay, you might see something like a negative 4 to the power of 0. Okay, when you're doing something like this, the negative sign does not get attached until after you have raised the power. Okay, so you might be thinking to yourself that the answer is positive, is going to be a positive 1 or something like that, because it's, when you multiply negative times a negative, it is a positive, but in this case it's separate, it's different. What we're going to do is just, we're going to leave this alone, and we're not even going to bother with it until we're completely done. So 4 to the power of 0 equals 1. But the sign is negative, so we just carry the sign over to the answer, and we get a negative 1. You might see some of these that have absolute value. The absolute value of negative 10 raised to the power of 0. Well, when you're doing the absolute value, when you're doing something like that, you have to deal with what's inside of there first. So the absolute value of negative 10 is just 10. So you have 10 to the power of 0. And we know that 10 to the power of 0 equals 1. You might see something like, and I'm telling you because I've seen it. Let me move this up so I can have some more room. You might see something like the negative absolute value of 14 to the power of 0. Okay. Let me make this a little more obvious, and I can't draw very well. Okay, but these two columns out here, this is the absolute value, and I don't know whether it's called is a bracket, or the one thing that I've never known is exactly what they call these things, but it's just two vertical lines on the left, on either side of the number. That's the absolute value sign. So the negative absolute value of 14 to the power of 0. So basically we're going to get the absolute value first. The absolute value of 14 is 14. 14 raised to the power of 0 equals 1. The sign over here that we still haven't dealt with gets applied after the fact. Now, if you're going to have the absolute value, the negative absolute value of negative 14 to the power of 0, then basically the absolute value of negative 14 is 14. You raise that 14 to the power of 0 and you get your 1. Man, I have such bad handwriting today. You raise that 14 to the power of 0 and you get your 1. And then you take the negative sign from over here that you haven't dealt with, and your final answer is negative 1. And these kind of absolute value things, the things you do with your signs, and this also applies to, what do we do? One up here. We can go over here. Okay, when something is raised to the power of 1, it is itself. So after 0, you can say that we've done power of 1. For example, 8 to the power of 1 equals 8. And so forth and so on. So when you're dealing with absolute value or even a parenthesis, you will often see something like that. And in this case, it would just be negative 8. You raise the power to 1, which means you get your 8, and then you apply the negative sign afterwards. Now, okay then. Well, we've covered a lot of stuff today, and I'm going to go ahead and put this video up. Stay tuned for the next video. I haven't decided what it's going to be yet, but I can tell you what, I am pretty much done with, no, I'm not done with exponents. In the next video, we'll actually have some problems that will show you how to implement these techniques. That's what we're going to do. Okay, so stay tuned, and I'll see you next time.